bass. Bass is always an issue in acapella. Because here's what the engineer does. They do this. Because that's what the EQ would be for a lead singer, right? With the roll off and red spot, and then they boost the low end. And what they think, what most engineers think low end is for a voice is 200 hertz, which is mud, right? Mud, 200 hertz. You have to remember that. What they don't realize, what most engineers don't realize, is that there are sub-frequencies and sub-harmonics that happen in the voice and in the chest cavity that you need to capture. And those happen as low as 50 hertz, 40 hertz, octaves below the note that they're singing. So if I'm singing 100 hertz, which is about the note that below that would be it's just not there. But it does happen naturally. So let's release the high-pass filter. No high-pass filter on bass. Write that down. I saw your pen move. Good job, man. And then I make sure that the subs are on. Yes, because the bass will actually hit the subs pretty hard. Believe it or not, engineer. And so we end up the octave is I can't sing that, but it would buzz it. It's there. If it weren't, you definitely hear it. I'm rolling off at 100 hertz. So that's when the roll-off starts. Right? So there shouldn't be anything below that. If I'm singing 100 hertz and that's where the roll-off happens, let's disable it. Hear it fill out? Exactly. There we go. You gotta tell the engineers that. They probably won't know. They won't expect that to be. But it really thickens out the sound. And what we're going for is the human voice being a very dynamic instrument. We're talking 40 to 50 hertz, all the way up to what we generally can't hear much, and that's 16K, 16,000 hertz. That's a very wide range. A human can only sing between, maybe if they're really low, 75 hertz, somewhere in there. And the human voice only goes up to, like 1.3. So if you look at a graphic EQ, I'll show it to you right here. Let me show you where the voice actually sits. Here's 20 hertz, here's 20,000 hertz. The human voice only goes from there to there. That's the only spectrum that the human voice actually sings.
So that and that.
Mm-hmm. Between there and there.
So the board's not that intimidating anymore.
No. So as an engineer in acapella, I'm really worried about this.
Right.
A lot. You know? What's below there is subharmonic frequencies, or kick sounds. I mean, if you're going to do the vocal percussion, it is below there, but it's not singing. And then above here, what's all this up here then? Why do we even have these faders up? Why do we even care about frequencies above 1.4 if we can't sing higher than that?
You have partial harmonics.
Diction, clarity, breath, air, all these things that make it a human performance are those frequencies above 1.4. And so those are very important too. The bite of my voice. Let's turn it on, actually. Now let's put in, let's find the bottom of this. Where am I singing? So the highest I can sing will be. That's all the frequencies of my notes. But you don't hear hearing the T's and the D's and the S's and stuff, unless you're hearing it right here. You know what I mean? All these are the clarity of what you're doing. Check, 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 check. Let's bring those back in. Hey, 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 hey. You're going to start to understand more about what I'm talking about. Huh. I'm not talking in this frequency, but it sure is nasty. Right? It's an overtone of my voice. And then you're getting into T's and D's and S's that actually make it so that you can understand what the heck they're saying up there. So, if your group's up there singing a bunch of words, and no one can understand what the words are, there's nothing to do with here down. There's everything to do with here up. Everything above 1.4. T's, D's, S's. All that. That's a basic, quick EQ lesson. What I would suggest you do is find a graphic EQ that has 31 bands of EQ on it. Put it through a sound system. And figure out what those frequencies sound like.
There's one in iTunes. Yeah.
We'll just pull up a frequency analyzer and show you. So, my next thing that has to do with EQ is eliminating feedback. Remember, remaining transparent to the audience. You, as a singer and an engineer, can help the engineers that are mixing you. If they have feedback and it's not going away, you can tell them what frequency it is if you learn them. Say, dude, it's 1.6K. Really? They'll turn it down. Oh, feedback goes away. So, there's a frequency analyzer. It's showing the 31 bands that I have here on the mixer. So say you get a feedback at just a little above 2K, so 2.5.
How do you know without that?
You learn them. I'm giving you the tool, but what I do is I learn what 300 decibels. I know that I can only whistle up to 3.15. If it's above that, then I know it's above 3.15. But if I can whistle it, I know it's that. If I can sing it, I know that it's below 1.4, right? And then all my vocal range, I figure out what those are. If I can't sing it and it's too low, then it's definitely below 80. And you'll feel it below 80 too. That's how I figure it out. Hertz. It's not totally out of the mixer. You still hear it. But if you have a feedback, it just means that either this microphone likes that frequency, or it's made and manufactured to have that frequency a little boosted, or your mains have that frequency that's a little accentuated because of the way it's made, or the amplifier, several different factors. When you cut out that feedback, it's not going to hurt your sound. It's not going to make other things sound bad. What it's going to do is make it finally sound even. So learn your frequencies, what they mean, bud, bump, tinny, all that. And then also learn how to get rid of feedback. You hear it, you sing it, you whistle it, you know what you can whistle, you know what you can sing, and you can get rid of the feedback based on that. So what you end up with is a microphone in front of a speaker that is loud and doesn't have any frequency issues, no feedback issues at all. So I'm going to create feedback right now. This is going to be fun. We're going to figure out what this microphone is all about. So, let's flatten our EQ. Just have a little time. I'm going to make feedback, and then I'm going to teach you how to get rid of it. Woohoo! I'm going to use the analyzer. Or should I not? We'll take a guess. We'll just take a guess just to see what, So, we're going to get my microphone way too loud. Check, check. what's the octave above 2.5? 5. Double it. 5. Always double. So let's go to 5K. We're going to turn it down 5K. Now we're going to turn the microphone up again. You can hear the system's really loud, right? Here comes another one. My guess is 250. Two harmonics of each other. Oh, that's that one I had a problem with last night. That's 4K.
You remember.
I remember that one, but it's a different mic, so obviously that's an issue with the room or the mains.
Well, make the mic pop like that. What sound comes.
Yeah, that was a frequency radio interference. Thing's loud, man. That's cool. It's not me. Oh, 200. Oops. Cool. No, wait a minute. So now, I mean, this microphone is absolutely loud. But we found the ceiling. Now I know that I can put it into a normal place for the show. And I've got this much fader room. I know that if I need it during the show, the soloist is really quiet, I can be okay.
So, Tony, what happens if you need to pull down a frequency for the feedback, but that's the frequency you need for the kick, or for the clarity of the vocal, or something like that?
It's actually okay. You're taking a node out. You're taking out a peak that is naturally in the room, or in the ear, or in the microphone. So when you take out that peak, it actually flattens it out. Everything else around it is going to sound the same. This microphone doesn't sound any worse for taking out those frequencies. It actually probably sounds better. Because we took out those nodes, we took out those issues, we took out whether it's standing waves in the room because of the dimensions of it, or because of the manufacturing in the cones and the drivers and the speakers have different frequency characteristics. So usually it doesn't do anything. When you're working with a band and you have multiple brands of microphones, they're all going to have frequency characteristics and feedback characteristics independent of each other. That is when you would use the channel EQ to take care of some of those issues. We won't compromise the sound of that specific instrument. And it will take care of the feedback that's happening on that microphone. So then you blend all the two together, or blend all the microphones together for the band, and then you have, once you have all the harmonic stuff going on in the room, you're going to find room issues too that weren't there when you played music. The band being live there, you're going to find some other harmonic stuff that happens because of the size of the room, length, width, height, and sound waves bouncing off a wall and multiplying on each other. Standing waves, those are called. Nodes, standing waves. And you'll hear those frequencies come out and mess up your sound. All of a sudden it gets muddy when everybody plays. I specifically tune a room with take 6. I take out so much of the low mids. I take out a good chunk of 100 hertz, a good chunk of 125, 200, 250, and usually a little bit out of 400. Knowing that when their voices blend together and they ring a chord, I'm going to end up with issues at those frequencies every single time, no matter what room I'm in. I'll tune the room, they sing in it, I still have the same issues. It's not the room, it's the guys, they have issues. Just kidding. Every group I find, just based on the voices that are in the group, I'll find different things. Different things that go on. You guys, 2K.
What's 2K? What about it?
2K is a very bright thing.
Well,
It makes your voice very bright.
I don't know
And
what you're talking about.
individually you sound great at 2K, but you put Drew and the girls together, man, 2K hurts. You know? So, telling your sound guy, hey, 2K might get a little rough with our voices when we blend. Yeah. No, got 2Ks. Yeah, more pleasing. But those are things that all groups have those because we're all putting together 6 instruments on stage, and they're all the same instrument. And that's the last thing I tell an engineer when I walk in is, hey, it's like mixing 6 guitars. That's what mixing a cappella is going to be like. You have 6 of the same instrument up there. They all have different timbres and stuff, but it's all the same instrument. And we would like it to sound clear. And they're like, oh yeah, guitar. They get it. Yeah.
Do all sound engineers I don't know, this sounds familiar, but speak that same language of 2K and 4K? If I just went up to someone who has experience with the soundboard, would they know what I was talking about?
Yes.
Oh, shit.
They should.
They should.
If they don't, then
They shouldn't be up there.
if they don't, then
Just picking on my
you know what boat you're in. That's all. You know what you're going to be tackling that day. Because those are the specific things that make music sound good or bad. Is EQ, treating the room. Can't shine a turd. If you play good music in a bad room, it sounds bad. Any other questions? Yeah.
With 14 individual wireless mics, how important is it for you to know who's on which mics? It's very important. So how, with groups like us, you don't know who we are and we just walk up there, we grab each individual mic. How do you know which voice is coming out of which mic?
Yep, there's a number on it.
Okay.
And I know that number is lined up with the board. And so if sound check, you grab that number, and then in the show you grab the same number.
Gotcha.
That'll be fine. Because I'll know who sings the solo. On those, I have a lot of blanket settings. A good basic clean sounding EQ setting on all the voices. Because it's such a group number. With 6 voices, I individually get each voice sounding as good as I can. Now, if I work with 14 voices every night, then yeah, I'll be dialed in even more. Yeah. So I'll write down as we go. I'm going to write down, cadence 5 for song solo 5 and comma 2, comma 3. So 5, number 2, number 3 through the song. So I know who to bring up and who to be ready for.
I like a 2-part question. First off, how do you work with area miking? Because my group's too big. I don't have access to a board, so I've got to keep that one. So I usually area mic with 2 or 3, but then I want the soloist and the beatboxer and sometimes the bass on a mic. How do you balance an area miking sound versus how do you find a balance between, or what's your process for finding a balance between area miking and still getting a good loud sound when you still have some specific voices on miking, but you want it all to be balanced?
The key to area miking is doing what I just did. Bringing those up, ringing out all the feedback, so that you can get more signal before feedback. Your signal to noise ratio is what you're going for. Technical term meaning exactly what I just did. I brought it up so that I created feedback and got rid of it so that I have more signal. And more signal before the feedback. I would do that with 3 mics for an area miking thing. 2 mics set back a hair and then 1 mic set forward a little bit in a 1-to-3 ratio. 1-to-3 ratio is the way that the microphones don't have as much phase cancellation or frequency cancellation between them. They listen to each other. And when you play, you put 2 microphones together and you mic 1 sound with it, depending on how far away those mics are from each other, different frequencies will actually cancel themselves out. The best way to not have that happen is have 3 microphones and have them 3 feet apart and the middle microphone be a foot forward. 1 to 3 eliminates most phase cancellation. That's the first thing. Number 2, bring them all up and ring them out. Get that signal up so that you can take that signal of your group and balance it with the single mics that you have for percussion bassing. But the key is the area mics having a good signal. Without that, you really have a very unbalanced thing and you can't ever get it right. Was it anything else? Yeah.
Oh, what do you do if like you normally are doing for like marriage? Now that I'm in it, I have to train someone. They can just do 4 marriage. How do you convince to them just the basics of what they need to get so that there's still a good sound with not as much training? Or do you just, like if they can't comprehend it, what do you say that makes them click? What do you...
If start basic and work to the details. First, they have to learn how it works. You plug it in, you turn this knob, you put up that fader, and it works. There's sound. Signal flow. Signal flow. It comes from the microphone, it goes through the cable, it goes into the mixer, and then we turn it up. Signal flow first. Second would be general EQ. They go straight to EQ. Because without that, it's always going to sound bad. After EQ, then you start working with multiple miking situations, starting to get blending things together. And the last thing you do is work on effects. What good is putting a nice reverb on something if it's totally not blended and not EQ'd right? It's not going to make it sound better. You're just going to wash out more of the bad stuff. So, yep. In a situation when I'm working with a group that isn't as talented, that isn't as good with mic technique and stuff, I worry all about blending them and getting their material to sound better in the room before I ever go to reverbs. So with Take 6 or more experienced groups, they do a lot of the work themselves, blend themselves very well. They already sound very good on their own. And I can almost just leave the faders alone, and then I'm free to do creative stuff, like the echo stuff, or the subharmonic stuff on Johnny last night, or all the fun stuff. So that's the advanced part of it, is working toward the creative, but taking care of your basics. Okay, basics first. Anything else?
I'm not too familiar with live sound, so do you approach it the same way you would a recording? Like, do you pan, individuals throughout the field, I guess, like some are left, some are right? Do you do that kind of thing? Do you add compression at any point, or do you expect them to kind of do it on their own with mic technique?
Well, hopefully they do it on their own mic technique.
No.
But if not, then yeah, I'll put a light compression. Compression in a cappella and compression on vocals takes away some dynamic contrast, which is what you really want. So if I compress, it's no more than 2.5 on the ratio. That is. And the threshold is only kicking in when they're really getting into it.
And in terms of panning, does that help at all?
Panning, I generally don't do it in live situations because if you pan people left, the people in the right won't. It's the wrong mix for them. This type of hall is not too bad. Maybe the first 7 or 8 rows would hear that difference, and it would sound weird to them. Everyone else would think it sounded a little better because voices are a little more spatially put out there. But you are compromising it for some people in the audience. So generally, no. Anything else? What time?
Time to go.
Time to go. All right. Hey, email me. You can find that on the Mile High Vocal Jam website, or Tony@take6.com, or my website for the studio and stuff at sonicaudiopro.com. Tony at. Yeah. Thanks. I hope you learned something.